right, ladies and gentlemen, we're going to get started up in a moment here. Angelo, I'll be handing it to you in just a second here. I do want to say, Alberto, it was your name I forgot to say before. So, Alberto and Angelo, both of you, thank you very much for everything you were doing in chat during the first event. Lots of great questions in there. So, I do want to say thank you to both of you. With that, then, Angelo, I will hand the show over to you, and it is all yours, sir.
Thanks. Thank you, Charles. Okay, so let me just share my screen here. Screen. Yep. Okay, so what we'll discuss for this section of today's workshop is some basic troubleshooting. First of all,
when you get back to the actual demo part, Angelo, if you could zoom in a little bit more, I think that'll be easier in everybody's eyes if you could.
Yep, I will do that.
Cool, thank you.
Cool. I'm not going to go through all the slides here. One, because there's a lot of them and we don't have a lot of time. And two, we have some resources here where we've actually recorded these data plane troubleshooting sessions from before. Also, we have some Global Protect troubleshooting videos up on our YouTube channel. So I won't be going through all of these slides, but they will be provided to you. What I'm going to do is I'm going to demonstrate these 3 tools that you can use here when you're troubleshooting transit traffic issues on your firewall. Okay. So first up, how do you gather basic information? So that will be under monitor and your logs over here, whether that be traffic, threat, or URL. So what's happening in my lab is that I have a ping that is not working. As you can see, there is 100% loss from my last instance when it ran, and right now it's still not working. So some basic information in your traffic logs, you will have this. Now, what's not immediately available to you are the packets sent and the packets received. So these 2 are important because it shows you whether there's actually bidirectional traffic, as you can see here. So these are my pings. I can only see that the client is sending out the packet. There is no response from the server. So I can then focus on which segment of my network I need to check. So this will be on the server side or on the LAN side or on the WAN side, since this is the internet. Another thing that you can do here in the traffic logs is build your filters. Anything that you can click on here will always build your filter up over the top here. Now, you can use logical expressions such as and, or, and not. So say you want the application to be pinged and the source address to be this source address, and the destination is, or you're looking for any traffic log with a destination of 8.8. Okay, so you can do that. You can also segregate your logical expressions, search expressions here by using parentheses. You have your and or operators, or you can have your not operators there. So this is quite useful when you're looking at when you're trying to review your traffic logs, looking for for traffic that's not working. In addition, you can specify a timestamp. Sorry. Okay, you can change the operator from less than or equal to greater than or equal to, and then this will give you a time frame. So your greater than or equal to time will be your late or your oldest time that you were checking, say 7 a.m. 7 a.m. on October 21 until 7 p.m. October 21. Just an FYI, my firewall isn't PST, so it's still October 21. So this way you can find out, you can reduce the logs that you have to sift. Okay. Another thing is, do not forget this small icon here. It's easy to glance over, but that gives you a whole lot of information, not just for the traffic statistics, but also for the information that you will see here. Because even though the action is allowed, if you have security profiles attached to your security rule, such as URL filtering or antivirus or vulnerability, there can be a block action depending on the layer 7 content of that traffic. So even though the security rule is showing as allow, there can be additional information here if the traffic is being blocked. So if it's blocked by URL, you'll see a URL block showing information here. Okay. Now, what else do they want to show you? So the way you enable these additional headers here is by clicking on any of these drop downs and then just picking the appropriate box you want to see. So right now we are seeing that the client is sending the packet. We're not seeing anything from the server. Another useful, other useful headers you will see here is the ingress and egress interfaces. So here we're getting a picture of what's going on with the traffic. It's coming in Ethernet 1/2, going out Ethernet 1/2. Now, normally that would raise some suspicions as to why that's happening, but that depends on how you set up your network. If you've set up the network to be if you set up the device to be a router on a stick or a firewall on a stick, then this will be totally normal, right? So, but if you set up the firewall to not be a firewall on a stick, then this is already telling you what's going on. You have an issue with your static routes or your routes. Okay, and then with that, you will go to your virtual router, check your static routes, and then see what's going on there. Okay, so in this case, I purposely made an incorrect route just to demonstrate the tools I'm going to use. Okay, give me a thing. Now, if the traffic logs does not give you enough information, the next tool that you're going to use is the global counters, and you can only do that in the CLI. Okay, I will have some resources with global counters here later on, so these will be included in the slides. Okay. Now, to use global counters, what you need to do is you need to set up your packet filter. Be as specific as possible, 172.168.5. If you have your destination, you can do that as well. Put it in as well. If your destination is a website with a random, with different IP addresses because of its DNS records, I recommend you familiarize yourself with websites which has a more predictable IP address, such as time.is. So time.is has a predictable IP address here. Okay. As you can see, for time.is, it's always going to be these 3 IP addresses. So if something is not working, you can use this as your testing FPDN, as it will always have these 3 IP addresses. Okay. Okay, next, and if you know the protocol, specify the protocol as well as the ports, and then set that to OK, and make sure you turn on your filter. And that's all you need for global counters. So the next, how would you use global counters? It is only available in the CLI. So the command for that will be show counter global, filter packet yes. Filter packet yes, because we set the packet filter. Delta yes, because I don't want to see the whole history of the global counters. The global counters refresh every 10 minutes. So I don't want to see everything. I only want to see the delta of the counters from when I run this command. Okay. If you do not include these options, then you will get the whole history for the last 10 minutes of the global counters. That is helpful if you're checking the overall status of the or health status of the device. That's not helpful if you are trying to troubleshoot a very specific source or application that's not working. Okay, so always use these two. Run the command. When you run the command after a long time, ignore the first output. That's not going to give you helpful information. So run it until it clears up and nothing shows. Okay. Once you're not seeing anything, then initiate your traffic and then rerun the command again. So now we are seeing the the counters for the specific traffic that's being generated by my device. As you can see here, we have a drop. The reason or the description for that is the packet was being dropped because there was no ARP. So going back to the GUI with the traffic logs, you might remember that the packets were actually being sent. So this, if the traffic logs are not sufficient to explain or resolve the issue, then you will need to use global counters for the packet diagnostics. Okay, so it says no ARP. So at this point, we can do two things. One, check the ARP table. Two, run a packet diagnostic to see why what that no ARP means. So let's do the first one. Show ARP all. Okay, that's a lot. Clear ARP all. Clear ARP space all. ARP all. Okay. We are seeing something that is incomplete. 172.161.10. If we check our configuration, so that is the next hop IP of my static router. So from there, you can resolve this issue. If you are a router on a stick, then you have a layer 2 issue because that device is not responding to the ARP request. If you're not a router on a stick, then you have a misconfiguration of your static router. Okay. Now, say you did not check the ARP table and you want to know more about what this means, you can run packet diagnostics. To set up packet diagnostics, you are already a quarter of the way there if you set up the filters for global counter. So the next thing that you need to set up are your packet captures. You can put in any file. You can use the same file name for all of these stages, but we recommend that you save them into separate files because it's easier to merge them together if they are in different files in Wireshark later on, rather than to separate them into individual files that you need for analysis. Also, we do them in these different stages so that we know where to where the issue is happening. As an example of that, dataplane. Hold on. So when you run a packet diagnostic, there are quite a few options that will be available to you, but the most basic one is going to the flow basic. Okay? What the flow basic does is it tracks the packet as it goes through these different stages. So when a packet comes in ingress, it will log that the processing performed on that packet, and then it will either move on to slow path or fast path, content inspection, app ID, and then forwarding ingress. So that gives you the basic information of how the packet is moving around inside the firewall. Okay? If you want to know more about the different types or the different or more details about different processing stages, you can request for that in a future field workshop. Okay. Okay. So now we have these stages here. Transmit. Okay. After configuring the captures, that is not yet the whole picture for packet diagnostics. You need to configure the over here. you need to configure the actual diagnostics in the CLI. The command will be debug dataplane packet diag. The command will always start with these three keywords. So first, let's see what we've set. We've set our packet filter. We have also enabled our packet filter, and we have our filters here. You'll notice that the filter is showing a host subnet or a /32 subnet. You can't use a /24 any subnet mask, but you can only do that in the CLI. Debug data plane packet diag, set filter match, source, oh, 0, source, net mask, diag, show setting. So here you'll see the /24. Okay? Now, once you've configured this in the CLI, the subnet in the CLI, do not change anything in the GUI. So in the GUI, you're not going to see the subnet mask there. And if you change anything in the GUI, say I just include the protocol here, that will override your CLI. So if you're keen to use a subnet as your filter, do that in the CLI, and then don't change anything in the GUI. Okay, we have those filters. We don't have logging configured. Nothing is configured, and it is also not enabled. But the packet capture is configured, as you can see here. But right now, it's not enabled. So this is the next part that we're going to configure. Okay, the command for that will be debug dataplane packet diagnostics, set logging feature, and then always start up. Again, there are different features for that. If you want to specifically check the app ID over here, here we go. Over this part, the pattern matching for the app ID. Say your app ID or your application is not being identified correctly, then you can use app ID. For now, we will start with flow. Under flow and under all of these other logging features here, there will be different options, but there will always be the basic option. Always start with the basic. Now we check our setting. We have logging not yet turned on, but it is now configured with flow basic. FYI, the logging will turn itself off after 60 seconds by default. That can be configured. Find command keyword logging. Logging. No. Bug data. Yeah, we have set log timeout. Okay, so you can disable it or set it to 1 hour. This is configured with 60 seconds by default, just as a protection mechanism, because we have had issues in the past where the packet diagnostic was left running, and then the customer complained that their data plane CPU went high, okay? And that's affecting other traffic. So
Hey,
by default,
sorry, if I can throw a quick question at you. One of our attendees, Anise, if I hope you pronounced your name correctly, mentioned that you said a website before of IPs for URLs. Was that MX Toolbox?
Oh, yeah. MX Toolbox is used for checking different records. You will have DNS record, MX record, blacklist check, anything else.
Yeah, we were asking for the URL for it. Somebody else, as I asked you, somebody else, of course, put it into the chat, so we're good.
Okay, cool. Yeah,
thanks, sorry
this is useful for checking records.
Oh, yeah, no, I've used MX Toolbox before. It is fantastic. I just didn't realize that's what it was. So, yeah, thank you.
No worries.